Hello students, how are you? Fine, okay. So I hope you all are doing well and today is a very good day. Why? Because we all enters in the syllabus of class 12 from today's class, right? And I start the chapter in this class is function. Okay, function is just a part of differential calculus, and for your knowledge I want to say the calculus is broadly divided into the two parts, right? First one is differential calculus and second one is integral calculus. ठीक है? And differential equation basically contains the chapter like functions. First chapter is functions, then limits of function, continuity of function, differentiability of function, right? And last one is application of derivatives. And on the other hand, integral calculus contains the chapter definite integration, indefinite integration, okay, and area under the curve, okay, differential equation. These chapters contains in the integral calculus, right? So first of all we start the chapter from differential calculus, which is called function, right? Chapter name will be function. Right. Firstly, I want to give you a basic idea what is function. Okay. So don't write anything. It's just a basic idea. Basic idea. Don't write anything. Okay. Let us take two variables. Right. Two variables. Let us take two variables. Tell me anyone, two variables, any two variables. It doesn't matter which variable you take. Let us take x and y. Right. Now, x and y, there is a relation between x and y. Either x is equal to y is equal to x plus 1, y is equal to anything. Okay. X is greater than y is greater than x, or x is equal to y, x is equal to y plus 2. Okay, y is equal to sin x. All these are relations between x and y. Right? Now, we can also take y is equal to e to the power x, y is equal to cos x, y is equal to log of x. Right? All these are relations between two variables x and y. Isn't it? But is all the relations are function? Never. I don't know which is function or which is not. Okay. So what's the condition? Maybe here some are relation, some are functions. Okay. But it's not necessary all the relations are function. So what's the condition we put here, or what's the criteria for deciding which relation is function or which relation is not a function? Okay, so write down the definition of function. I am dictating you. Let A and B, capital A and capital B, be two non-empty sets. Be two non-empty sets. Let capital A and capital B be two non-empty sets. Then a function from set A to set B. Then a function from set A to set B is a rule which associates the element of set A, to elements of set B, such that all element of set A, all element of set A associates to an element of set B, and second, all elements of set A has all elements of set A associates with unique element of set B. This is the most highlighted part in the definition, right? All elements and unique. All elements. Okay, this is a highlighted part. This is most important part, right? I am going to explain the definition, but below the given definition, write down. I am dictating you. Write down. A function defined from set A to set B. A function defined from set A to set B may be written as okay, anywhere in this chapter, if you see the representation like that, then the meaning of this representation is that a function defined from set A to set B. Okay, and map and correspondence is used as synonyms of function, right? In place of function, we can use mapping and correspondence also, right? And the representation of function defined from set A to set B is this and this, either this or this. Okay. Now I am going to explain what the definition says exactly. So fully concentrate here. Very interesting and very important. Okay. Students, let us take a two set. Okay, the first requirement of the definition is we have to take two sets. Let us take A is equal to 1, 2, 3, 4. Right. Now B is equal to A, B, C, D and E. Isn't it? A and B are two non-empty sets. Now the question arises, what is non-empty set? Okay, non-empty set means the set contains at least one element, right? It doesn't matter how many elements are put in the set A. Okay, it's maybe 10 elements, it's maybe 100 elements, it's maybe 1000 elements. It doesn't matter. But the set A contains at least one element for non-empty set. Okay. At least one element. If we take A is equal to 1, then this is also non-empty set. If we take A is equal to 1, 2, 4, this is also non-empty set. Why? Because at least one element are there, right? Now the first requirement of the definition is A and B are two non-empty set. Okay. So here I take two non-empty set A and B. The set A contains 4 elements. Okay, 4 elements 1, 2, 3, 4. This is a non-empty set, right? And set B contains how many elements? Tell me anyone. Exactly, 5 elements are there. So B is also a non-empty set. Okay. One, 2, 3, 4. A, B, C, D, E. This is set A and this is set F1 is a function or not. Okay, function F1 is a rule. What is the meaning of rule here? If we write y is equal to 2 plus x, this is also a rule. Why? If we putting x is here independent, if we putting the values of x, then we can got the corresponding values of y. Okay, so this is a rule. Similarly, y is equal to sin x. This is also a rule. Similarly, F1 is a rule. Okay. Now our purpose is to check F1 is a function or not. Okay. So A and B are two non-empty set. First condition of the definition is satisfied. Now the second condition is all element of set A. All element, not does not be left a single element. Okay. All element, most highlighted part of the definition. Okay. All elements means 1, 2, 3, 4. All elements are associate. Associate is just, we can say that the associate means connection. There will be a connection. So A associates with A, 2 associates with B, 3 associates with C, and 4 associates with D. Okay, this is a association. Means first point only says that all elements associate with set B. So first condition is satisfied because all elements, there will be association of all elements. Okay, there is an association of all elements. Okay, first condition is satisfied. Now second condition, all element of set A associates with unique element. What is the meaning of uniqueness? Unique element of set B. Okay. Here uniqueness is exists. Okay, because first element goes to A. If first element also goes to B, then this is not unique. Okay, because one goes to two association. One has two association. One goes to A, also one goes to B. So we cannot say that one has unique association. Right? So now one has only one association with the element A in the set B. Okay. Now 2 associates with B, it's also a unique. 3 associates with C, it's also a unique. And 4 associates with D, it's also a unique. Okay. So the function F1 satisfies all the necessary condition of the given definition. Right. So we can say that F1 is a function. Yes. This is a function, right? Now similarly we can take another example, F2 function. 1, 2, 3, 4, right? A, B, C, D, and this is set A and this is set B, and this is a rule F2. Okay. Although set A and B are non-empty set or not? Exactly. This is a non-empty set because 1, 2, 3 are 4 elements and 5 elements are there. Okay. Now, first, if we take it on like that. Tell me anyone, this is function or not? First element, first point, what is? All element of set A associates to an element of set B. All elements. Okay. Highlighted the word students. All elements. And 3 is also here. But there is no association of C. Okay. There will be no connection of C to the element of set B. So this condition is not satisfied here. We cannot say that the F2 is a function. Okay. Because here there will be no association. There is no association of element 3. Right? So we can say that this is not a function. Isn't it? Now I will take another example. 1, 2, 3 and 4. Okay. A, B, C, D, E. This is a rule F3 and this is a set A and B. Now A and B are non-empty set here. Okay. A and B are non-empty because 4 elements are set in A and 5 elements are in set B. Okay. Now first condition, all element of set A, all element 1, 2, 3, 4. There is a connection of all elements with the element of set B. Okay. Now first element goes to A, unique association. Okay. Second element goes to B, unique association. Third element goes to C, it's also unique. Okay, in the definition, there will be no any restriction in the set B. Restriction is only put in set A, isn't it? So 3 has unique association and 4 also has a unique association goes to C. Right? So all the condition of the function is satisfied. So we can say that F3 is also a function. Okay? Yes. This is also a function. Similarly, we take another example. Set A and set B. 1, 2, 3, 4. A, B, C, D, E. Now tell me anyone, this is function or not? This is F4 clear rule. This is a function or not? Try students, at least try at once. Exactly, this is not a function. Why? Anyone tell me? Anyone wants to tell me? Exactly. Because 2 has all elements, if all first condition is satisfied, all elements associated with a element in set B. But 2 has not a unique association because at the same time 2 goes to B and 2 goes to C also. So second condition of the definition is not satisfied, unique association is not satisfied, so we can say that the F4 is not a function. Okay, this is not a function. So I think everything clear about the definition of function. This is very important and very interesting, I think. Now we move towards the some important definitions. Write down the heading. Write down the heading, some important definitions. Some important definitions. Write down first domain. What is domain? Write down, I am dictating you. Let f is a function from set A to set B. F function from set A to set B be a function. Be a function. Then set A is known as domain of the function. Then set A is known as domain. Okay. Suppose here we take A, B, C and here we take 1, 2, 3, 4 and F is a function defined from set A to set B. Okay, so what is domain? Domain is set A. The elements which is present in the set A is called the elements of the domain. Okay, this set is called the domain of the given function. Okay, write down next point. Set of, this is another definition of domain. Set of all those points. Set of all those points from which function is defined. From which function is defined. Right? Now tell me anyone, which set A and set A is domain or set B is domain? Exactly, set A is domain. And what's the element in the set A? A, B and C. Right? So domain set A is equal to A, B, C. Isn't it? Set A is called the domain. Okay. Now next definition. Next definition is codomain. Codomain. Write down. Let f such that a to b be a function, then set B is called the codomain. Set B is called the codomain. Right? And alternative definition, write down. Set of all those elements into which function is defined. Into which function is defined. Isn't it? Here, concentrate here. A and B are two sets. F be a function defined from set A to set B. Okay. This set is called A. This set A is called domain and set B is called codomain. Okay. So elements in codomain are 1, 2, 3 and 4. So codomain set को हम क्या? Codomain is equal to set B 1, 2, 3, 4. Right? Codomain set is B and domain set is A. Right? Now, move towards the next definition. What is a range? Third definition, range. Suppose students, we take two sets A and B, right? And first set A contains 3 elements and set B contains 4 elements, right? And F is a rule, F is a function, right? So, in this way, this set is called codomain and this set is called domain. Okay, but range is the association. Means only we take the elements which associates, then that set is called range of the function. So here range of the function is equal to 1, 2 and 3. Right? So we can write, नोट करके लिखिए, range is subset of codomain. Why smallest subset, right? So codomain means all, and range means only the elements which there must an association or connection, right? So connection is only in the 1, 2, 3. 4 is left. So total is codomain, and this the connection is only associated elements are 1, 2 and 3, right? So this is a range of the function. Okay. Now I explain in the next lecture what is pre-images and images. Okay. So thank you for today's class.